All right, so now that we've managed to get our program to encode some text, it's time to do the opposite direction, which is how do we get our program to be able to decode a piece of text based on a shift number? So let's say that we try to decode the letter G and we had a shift number of 3. Well, in this case, we actually have to work backwards and shift backwards in the alphabet in order to get the letter that's 3 spaces previously. So go ahead and open up the step 2 of our Caesar Cipher project. Now we've got all the code from the previous lesson, and we now have to complete 3 more to-dos to complete the decryption part of our program. So the 3 to-dos are you're going to create a function called decrypt that takes also 2 inputs. Then inside the decrypt function, you're going to write some code to shift each letter of the original text backwards in the alphabet so that we decode it to the original text, and then we print out the decrypted text. Finally, we're going to figure out how to combine the encrypt and decrypt functions into a single function. And then within the function itself, write some conditional statements to figure out whether if the user wants to encrypt or decrypt using this direction variable. And then we end up with a single function rather than 2 functions, encrypt and decrypt. So I recommend to do these to-dos in order and not to go straight towards to-do number 3, because it's quite important that you understand how the decryption works and how it differs from encryption before we move on to combining them. So there are some hints in the description box as well, and there's some more details in the description for you to read. Once you're ready, pause the video and I'll go silent and wait for you to complete this exercise. All right, hopefully that went really well for you and you managed to figure it all out. It's really, really hard. So all of these projects are really hard because they don't just rely on what you've learned in class. They also rely a lot of thinking, a lot of thinking outside the box, a lot of Googling, a lot of figuring things out, and also that key skill of engineering, which is breaking down problems to small enough a problem that you can solve. So there is no way that you would be able to just breeze through any of these projects. So don't feel bad if that's not happening. But now I want to go through the solution with you in case you wanted to check your solution or you need a couple of more hints to figure out what's going on. So the first thing we're going to do is to create a function called decrypt. And this function is again going to take 2 inputs, the original text and also the shift amount. So now that we're passing in these 2 variables inside the decrypt function, we're going to shift each of these letters by the amount that is required based on whatever it is the user wanted. And then we're going to shift it backwards in the alphabet. So if the original letter was F and their shift amount is 2, becomes H. So now they're giving us H as the letter to decode. Then we take the shift amount and we subtract 2 and to get back to the original letter. So most of it is pretty much exactly the same as what happened in our encrypt. But the only difference between decrypt and encrypt is the shift direction. Because instead of taking the position of the current letter in the alphabet and shifting it up by adding the shift amount, what we want to do is we want to subtract it by the shift amount. So that instead of going in this direction, we're now shifting it down this direction. And the rest of the code is pretty much exactly the same. Let's walk through them line by line, just so that we revise what's happening. Firstly, we're looping through each letter in the text to decode. We're working out the shifted position, so the position of the new letter, by taking the current letter's position and subtracting it by the shift amount. Once we've got that shift position, we're using the modulo to divide that position by the length of the alphabet, which is 26 letters. And what that means is we're always going to be within that range of 0 to 25, and we're never going to go out of range of our list, which is called alphabet. Finally, we take our empty ciphertext and we add each of these letters as we loop through each of the letters in the original text, and we end up with the final ciphertext. Now, even though ciphertext is what worked for us previously in encrypt, it's probably not the best wording in this case, because the ciphertext is the result that we get after we encrypt some plain text. So let's just change this to output text. And we need to change it in all the places that we use it. And now we're ready to go ahead and test our decrypt function. So let's go ahead and call decrypt and pass in the original text, which is going to be whatever the user added to this input called text. And then we also add the shift amount based on what the user typed for the shift. So now let's go ahead and run our code. And this part is still not considered, so it doesn't actually matter what you type. And then we're going to check just one letter. So let's say that I have the letter A and I want to shift it down by 2. So remember, even though we can type encode or decode, the only function that's being called right now in our code is decrypt. So it should be taking my letter and shifting it down by 2. So if A is right here, then shifting it backwards will take it to Z and then to Y. So now let's go ahead and hit enter, and you can see that my decryption is working as expected. So now all that we have left to do is to combine the encrypt and decrypt functions together into a single one, because as you can see, they are extremely repetitive. They're so repetitive that I was able to copy and paste the encrypt function into the decrypt function to get the same functionality. So let's go ahead and create this new function called Caesar. And this function is going to take the original text as an input and also the shift amount as the input, so same as before. But in addition, I'm also going to add the directionality into this function. Now, instead of calling it direction, which will be a little bit confusing because am I referring to the direction variable here, or am I referring to the direction variable here? And you can see as soon as I write that, PyCharm is already giving me a warning telling me that it shadows the name direction from the outer scope, which means you're trying to create a new variable name that's only going to be used inside your function, but you've already got this variable name declared outside. Now, this will still work, by the way. This is valid code, but it's just confusing code. So let's change it. Let's call this variable encode or decode. It's pretty easy to understand, right? We're trying to figure out, do we encode or do we decode in this function? So I'm going to copy everything I had from the decrypt function, paste it inside my Caesar function. And now what I want to do is to change it so that whether if the user wanted encode or decode, I will make this function do the exact thing that they want and encode or decode the text. So what is the difference? Well, the only difference really is this line right here. Either we subtract the shift amount when we're decoding, or we add the shift amount when we're encoding. So in maths, as you might have seen in the little hint I had here, in maths, when you multiply a number by -1, you will reverse its sign. So positive 5 can become negative 5 by simply multiplying it by -1. And then if we add a negative number, that's the same as subtracting it. So this might be a little bit of a mathematical knowledge that you may or may not know. or may not remember, as in my case. But hopefully with that hint, you could work out that in order to have this line of code work both during encoding and decoding, all we need to do is to change that shift amount based on the encode or decode variable. So if encode or decode is equal to decode, well, in this case, we're going to take the shift amount and we're going to multiply equals it by -1. So this is going to change this value to the opposite sign. So if it was positive, it becomes negative. And that's what we want when we're decoding. Now, in this case, instead of subtracting, we can simply add. So whatever it is, when we add a negative number, such as in the case of decoding, it's the same as subtraction. And when it is encode, then this if statement is not going to trigger, and we have the original code that we have for the encrypt function. So this is a really neat way that you can get around this problem. So now all that's left to do is to actually call this Caesar function instead of encrypt or decrypt. So let's clear the code a little bit to make this file a little less confusing, so that we only have our Caesar function. And now I'm going to call this function Caesar and pass in the 3 variables that it expects: original text, shift amount, encode or decode. So text is the name that we had for the input of the message, and then the shift is the variable we had for the shift amount input. And finally, we also have the direction. So this is, of course, a positional argument way of calling this function. But if you want it to be more clear, then you can, of course, add in the keyword arguments. So now let's go ahead and run our code to see if it works. So I'm first going to type encode to encode my message. And I'm going to encode just a single letter to make our lives a little bit more easy. So now I want to encode, which means shifting it up, and I want to shift it up by 2. So A, then B, then C. So hopefully I get the result C. Now let's go ahead and rerun this code. So go ahead and run it again. And this time I'm going to say decode. So again, I'm going to use the same letter A, and I want to shift it by 2. And this time, instead of getting C, I now have Y, because our code is working as expected. And we only have a single function that achieves all of that functionality. Now, there's just one last thing that you might be bothered by if you have a little bit of OCD like me. I don't like the fact that this prints out, here is the encoded result, whether if it's decode or encode. So how can we get it to say, here is the encoded result when it is encode, and here is the decoded result when it is decode? Well, there's a really neat trick here, because notice that the word encoded and decoded in English actually both have the word encode and decode. And the only thing that they have in common is the D to represent the fact that it happened in the past. So for us, it's as simple as simply taking this part, adding in the encode or decode variable, adding D at the end, no matter which one it is, and this F string will now print out encoded result if it is encoded, and it will print out decoded result when it is decoded. So hopefully you managed to understand what's going on in the explanation, or you already got it by yourself anyways and you're just watching to check. But once you're ready, we're going to move on to the next step and complete our Caesar Cipher program.
Thanks for watching the video till the end. Please leave your thoughts below so we can discuss more about the topic. If you'd like to suggest a video that could help the community, feel free to message me on X or Instagram. We also share short videos on Instagram, so make sure to follow us there. Feel free to reach out. We'd love to hear from you, and might even create a video based on your suggestion. Thanks again for being part of our community. See you in the next video.